Every message you send, every transaction you make, every photo you share, right now, it's vulnerable. Hackers, cybercriminals, even rogue states, any of them can intercept or manipulate your data. But what if there was a way to make online communication unbreakable? The quantum internet promises a new kind of technology that could change security, make things faster, and even how we think about networks. The quantum internet. The internet we use today is based on bits, the smallest units of data that are either a 0 or a 1. These bits travel through cables, satellites, and wireless networks to deliver everything we see and do online. The quantum internet, however, uses qubits, quantum bits, which operate in a completely different way. Qubits can exist as 0, 1, or a state in between, thanks to a quantum phenomenon called superposition. Think of it like flipping a coin that's both heads and tails at the same time until you look at it. Now, add another concept, entanglement. When two qubits are entangled, changing the state of one instantly changes the state of the other, no matter how far apart they are. This isn't just an idea. It's already been proven in labs. Imagine using these principles to create a network where messages can't be intercepted without leaving traces. In a quantum internet, if someone tries to eavesdrop, the act of observation changes the data, making the intrusion detectable. This is what makes the quantum internet potentially unhackable. While it's still in development, researchers have already created small quantum networks in controlled environments. In the future, these networks could grow to connect quantum devices across cities, countries, and even continents. So why isn't the classical internet enough? The classical internet relies on protocols like TCP/IP to move data securely. Encryption methods such as SSL and VPNs keep our data safe, but not for long. Quantum computers, with their immense processing power, could eventually break today's encryption systems. The quantum internet doesn't just improve encryption, it makes it fundamentally different. Quantum key distribution, QKD, is a key protocol here. Instead of relying on mathematical algorithms to secure data, QKD uses quantum mechanics. It creates keys that cannot be duplicated or stolen without detection. Unlike today's internet, which transmits data in packets that can sometimes get lost, the quantum internet uses entangled qubits that stay connected. This could create networks that are both super secure and highly efficient, reducing latency and data loss. If the quantum internet is so revolutionary, why isn't it already here? The answer lies in the enormous challenges researchers face. First, there's the issue of quantum decoherence. Qubits are extremely sensitive to their surroundings. Even tiny changes in temperature or electromagnetic fields can cause them to lose their quantum state, leading to errors. Next is distance. While today's internet can send data across the globe using fiber optic cables and satellites, the quantum internet struggles to maintain qubit entanglement over long distances. Currently, the range for quantum communication is about 62 miles in fiber-based systems. To expand this, scientists are developing quantum repeaters, devices that can maintain and extend entanglement by correcting errors without duplicating data, which is forbidden by quantum mechanics. Another big challenge is the cost. Quantum networks require entirely new infrastructure, from quantum processors to specialized memory systems and ultra-secure transmission channels. Unlike the classical internet, which uses existing hardware, the quantum internet needs entirely custom-built technology. Finally, there's the question of standardization. The classical internet relies on well-established protocols like TCP/IP. The quantum internet, however, is still in its infancy, with no universal standards for how networks should operate. Researchers are experimenting with different approaches, but a unified framework is needed to make the quantum internet a reality. Despite the challenges, the potential of the quantum internet is enormous. Here's how it could transform the internet. Cybersecurity. Today's internet is constantly under threat from hackers. Banks, governments, and healthcare providers are especially vulnerable. With the quantum internet, breaches could become a thing of the past. QKD ensures that any attempt to intercept communication is immediately detected. Imagine sending confidential files or making online payments with absolute confidence that your data is secure. Quantum computing networks. Quantum computers are already here, but their power is limited by their isolation. The quantum internet could connect these machines, creating networks of quantum computers that work together. This could solve problems in fields like drug discovery, climate modeling, and artificial intelligence, tasks that are impossible for classical computers. Global connectivity. Early prototypes of quantum networks have already demonstrated the potential for long-distance communication. For instance, Chinese researchers transmitted entangled photons over 1,200 kilometers using a satellite. These experiments are laying the groundwork for a global quantum internet that connects cities, countries, and even continents. Scientific collaboration. Quantum networks could revolutionize how scientists share and analyze data. For example, large-scale experiments like particle physics research or space exploration require enormous amounts of data. A quantum internet could transmit this information faster and more securely, enabling real-time collaboration across the globe. New technologies. Beyond just communication, the quantum internet could enable entirely new technologies. For example, quantum sensors could improve navigation systems, medical imaging, and environmental monitoring. Quantum entanglement could also enhance the precision of telescopes, helping astronomers study distant galaxies with unprecedented detail. Consumer impact. While the quantum internet might seem like something for governments and corporations, it could eventually benefit everyday users. Picture streaming 8K video without buffering or using smart home devices that communicate instantly and securely. The possibilities are endless. So, when can we expect the quantum internet? While no one knows for sure, progress is accelerating. In 2020, researchers in the Netherlands demonstrated quantum teleportation across 3 locations, a key step toward building scalable quantum networks. And in 2022, Chinese scientists achieved entanglement over urban distances using advanced memory systems. The European Union, China, and the United States have all launched major quantum initiatives aiming to lead this new frontier. For now, the quantum internet remains a work in progress, but its impact could be as transformative as the invention of the classical internet. The quantum internet isn't here yet, but its potential is undeniable. If you liked this video, don't forget to like and subscribe.